Let's look now at the code that implements the red-black tree. You can see the balance operation here first, which is just the same as the code that I showed you earlier on slides. This function is constant time. It's not recursive. It doesn't do anything other than pattern match against the first two levels in a tree to see whether the red nodes might be, and then rotate around and construct a new tree as a result. Below that, we have the insert aux function. Insert aux is my auxiliary helper function for insertion. It's basically the same code as insert on a binary search tree. If we're inserting into a leaf, it just creates a new tree that has two leaves as the subtrees, the new element X as the value at the node, and then it colors that node red, which is exactly what Okasaki's algorithm says to do. Always color that new node red, even though it might violate the local invariant. Then insert aux, as the insert operation for BST did, looks to see whether the element being inserted, X, is less than or greater than the value at the node, V. And it recurses itself down on the left or right subtree correspondingly, keeping the color intact. The only real change is the insertion of calls to balance in order to balance the result of each of those recursive calls on the way up and restore the local invariant. Finally, insert really just uses insert aux as a helper. The first thing it does is to match against the return value of insert aux to see if it gave back a leaf. Now that should be impossible. It is impossible. I'm only doing the fail with here in order to get an exhaustive pattern match. Really, the interesting work that insert has to do is to color the root black. And so that's what the final pattern matching branch does here. No matter what insert aux returned, insert is going to recolor it to be black to finish off the algorithm. So insert itself is going to be logarithmic time because it calls insert aux, and it's guaranteed to be logarithmic by that lemma and theorem we looked at before about the size and path lengths of red-black trees.